Hi, this is Mrs McTaggart. In today's video we're looking at how to find the area of a trapezium. Trapezium is always one of those shapes when I ask a class what's a trapezium look like, or show them the shape and ask for the name, they kind of forget this one. It does lend itself a bit to when we're doing composite shapes as well. So I normally teach it once I've taught composite shapes, which is when we split up into rectangles and triangles. But this is a picture of a trapezium. It's a four-sided shape. It is two-dimensional. The only interesting fact about it is it has two parallel sides, and that's the sides with the arrows at the top and the bottom here. To me, it always reminds me of like a roof of a house. If I was to draw a sketch as a child, this is how I would draw the roof of the house, because this is what the roof of my house looks like when I look at it. So it's got two parallel sides. Now this is a symmetrical looking trapezium. They don't always have to be symmetrical. So there's two methods here. One of the methods is going to be splitting up into rectangles and triangles, and then another method is going to be using a wee bit of a fancy formula one. This is just a couple of examples of where you might see some trapezium in real life. There's the classic roof one, there's this PE piece of equipment, and then there's like little shopping bags and things like that. So we're going to use method one where we split it into a rectangle and two triangles. Now what is missing from this diagram is a little bit of an indication that this is symmetrical. So I probably should put some lines there to show that. So this is a symmetrical looking trapezium. So what we're going to do is we're going to split it down here and have it as a rectangle and two triangles. And I'm just going to label these as area A, area B and area C. I always do area A as my rectangle because I always think that's the easiest one to find first of all. Area of a rectangle. So let's go with that. So the rectangle, if I just change my pen colour a wee second, the rectangle is 30 by 20. So for the rectangle, area A, we're going to write length times breadth, which is 30 times 20. 30 times 20 is 3 times 2 is 6 with 2 zeros. Area B is a triangle, which is a half base times height. Now I don't know the base now, so I'll come back to that, but the height of my triangle is 20. Okay, here's the bit we need to get the missing lengths. So if the top of the rectangle is 30, then that means this bit here is also 30. 40 take away 30 leaves me with 10. So the two little triangles must be half of 10. So that's going to be a 5 here and a 5 here. So the area of the triangle is half base times height, so it's a half of 5 times 20. You might look at that and go, these two triangles just make a rectangle. I'm just going to do it the simplest way I can think of for you to visualise what's going on. So I'm going to find the area of that triangle. So a half of 5 times 20 is the same as 5 times 10, or half of 5 times 20, which is 100. Either way, that triangle is 50. Triangle C is the exact same sum as above, so that's also 50. And the total area, when I add these all up, is 700. Now, there is another way of doing this. So I'm going to show you the other formula. It looks really complex, doesn't it? And it's one that's probably quite difficult to remember. But have no fear. Our backup is we split it up. Or there is a song. If you go to YouTube and Google area of a trapezium song, it will give you a little song played to the tune of Pop Goes the Weasel. And this is the words to the song. Please forgive me for what I'm about to do because I'm going to sing this to you. I am not the world's best singer. But it goes. Half the sum of the parallel sides times the height between them. That is how to calculate the area of a trapezium. Now I then play that to my class about 5 or 6 times until it jumps into the heads. Let's explain the words of that though. The sum of the parallel sides. Well, sum in maths means to add. The parallel sides are these ones which we've called A and B. So what it's asking you to do here is it's asking you to add A and B and then half it. Hence this part here is half the sum of the parallel sides. Then the times H. H is the height between the two parallel sides. So that is us timesing by the height between them. So the formula is just the song put in a different order. You might see the formula appear with the H in front of the half. I keep it in the order of the song because I try and get the song into everyone's heads. So what we're going to do is we're going to go and try this formula for our next couple of examples. Please remember we could always split this up and down into rectangles and triangles, but we're going to use our new formula now. So our parallel sides are the 32 and the 48, and the 20 is the height between them. So I'm just going to rewrite my formula. So it was half the sum of the parallel sides times the height between them. So it is a half of 32 plus 48. So 32 plus 48. And then we're going to times the height between them, which is 20. Right, so we always work out the bit in the brackets first. Remember BODMAS for brackets. 32 plus 48 is 80. So that gives us a half times 80 times 20. And then once you get to there, I've been doing these for ages now with triangles with my class. So we need to do half of 80 times 20. Options, half one of these numbers. I'm going to half the 20. Half of 20 is 10. 10 times 80 leaves me with 800. So the area is 800. Now I've been bad, I've not put units in on this one. So let's just pretend it said centimetres squared. So the area of this trapezium would be 800 centimetres squared. Or 800 square centimetres, depending how you've been told to say it. Let's look at an example. This is just a trapezium, but it's been spun around. So these are my parallel sides, the 11 and the 17. Now there's a wee red herring here. Which is the height between them? Remember, the height between them is the thickness of the trapezium. Think of it as being the roof of your house. How tall is the roof of the house if you were to spin it around? So it's 8 we're using. That 10 is a red herring. You never use the slopey bit. So area equals half the sum of the parallel sides times the height between them. I nearly sang again there. So let's put in the numbers. So our parallel sides are 11 and 17. And our height between them is the 8. So our new sum becomes a half times 11 add 17 is 28. And then times by 8. I definitely don't want to 8 times 28. So I'm going to half one of these numbers. I think I'm going to half the 8. Half of 8 is 4, so I've got 28 times 4 to go do. I could do a little sum at the side, but the trick for timesing by 4 is to double and double. So double 28 is 56, double 56 is 112. So the area of this one is 112 centimetres squared. Okay. So that brings me to the end of my examples. What I've got is I've got 2 slides of questions here. And then you can try these if you wish, and then unpause and the answer will be here. So there's my first 6. Again, here is the other 6. Numbers get a wee bit trickier on these ones. And then if you unpause, here are the answers written next to the pictures, so you can check answers as you go. Thank you so much for watching. I hope this has helped.